This is the History Guy, and today we're talking about the YB-49 Flying Wing. It was an American heavy bomber project designed during World War II that never quite moved past the prototype stage. The Northrop YB-49 was one of many flying wing designs developed by the United States during the war, but unlike many of its contemporaries, it featured a jet-powered design that was ahead of its time. The project began in early 1943 when the Northrop Corporation received a contract from the U.S. Army Air Forces to build a wooden mock-up of a swept-wing heavy bomber. The new aircraft would have a range of at least 2,000 miles and carry a bomb load of 10,000 pounds. The resulting design was a huge flying wing with a rectangular platform, a single fin, and a cockpit located under the wing leading edge. Northrop had previously worked on flying wing designs like the highly successful Horton Brothers HWK-2, which had been brought to the US and reverse engineered as the IN-1 M38. This was followed by the ambitious but ultimately unsuccessful Horton Brothers H-2X program, and these projects served as the basis for the YB-49. The team, led by Northrop's chief designer, John K. Northrop, created a radically different approach compared to conventional aircraft designs of the day. Instead of a fuselage with wings attached, they envisioned an all-wing design where the entire airframe functioned as a wing. This groundbreaking concept eliminated the need for traditional fuselage-mounted engines and allowed for more fuel to be carried internally. This design also offered advantages in terms of aerodynamics and manufacturing. Its flying wing configuration reduced the number of parts required, simplifying construction and maintenance. Additionally, the YB-49 featured a rectangular wing platform, which maximized both lift and internal fuel storage. This design choice set it apart from other contemporary swept-wing aircraft, such as the Avro Canada's CF-100 or the Gloucester Meteor, which typically featured tapered aero wings for improved performance at transonic and supersonic speeds. However, the YB-49's rectangular wing proved to have excellent low-speed characteristics despite its unconventional appearance. To achieve the desired range, Northrop incorporated 5 retractable landing gear with 2 large main units situated on either side of the wing route and 2 smaller units extending rear. These landing gear were fully retractable in the wells in the upper surface of the wing, reducing drag during flight. A 5th wheel was originally planned for the nose but was later omitted due to the removal of a proposed Norden bomb site. Unlike most contemporary bombers, the Y-49 didn't feature a traditional tail assembly. Its tailless design leveraged the wing's inherent stability and used a split brake chute for directional control. The brake chute consisted of 2 sets of small doors located on either side of the wing root near the trailing edge. When deployed, these doors opened upward, creating drag and allowing the pilot to steer the aircraft. A simple horizontal stabilizer bar was added above the cockpit to assist with pitch control and enhance stability. Powering this innovative design were the General Electric J35 turbojet engines. These engines were housed in jet pods that were structurally separated from the wing, ensuring that a malfunction in one engine wouldn't compromise the entire airframe. Interestingly, the J-35s were originally intended for use in the Republic XF, a tailless, straight-wing fighter project that was canceled in favor of the P-47. When the XF-84 project ended, the engines were repurposed for the YB-49. Each engine was rated to produce 2,600 pounds of thrust, giving the bomber an impressive power-to-weight ratio. Control surfaces were integrated into the wing's leading edge, consisting of 3 sets of ailerons near the wing root and 2 slotted flaps at the wingtips. The ailerons were small and individually linked, providing precise control authority. Construction of the YB-49 began in April 1944 with the first of 4 planned prototypes designated as the YB-49A. Despite its advanced design, the YB-49 faced challenges related to manufacturing techniques and materials. The airframe was primarily constructed from wood, laminated and molded plywood skin, covering a lightweight steel honeycomb structure. While this approach was suitable for low-speed aircraft, like the U.S. Navy's Wooden Avenger, the bomber's projected speed of over 400 miles per hour raised concerns about the durability of the all-wooden construction. Consequently, the project was delayed to allow for extensive testing of wooden aircraft at high velocities. In addition to the structural challenges, the YB-49's complexity and innovative systems require significant effort in prototyping and refining. For example, the landing gear, with its 4 main units and intricate hydraulic retraction system, posed considerable engineering challenges. Moreover, the aircraft's unique flying wing configuration presented difficulties in areas such as pilot egress and the integration of various systems. The first Y-49A rolled out of the Northrop factory in May 1945, just as the war in Europe was drawing to a close. With victory in sight, the U.S. military's interest in developing new aircraft waned, impacting the YB-49's development. The prototype's maiden flight took place on November 1945, piloted by Tex Johnson, who would later become a prominent test pilot. Despite encountering some minor issues during the initial flight tests, Johnson's subsequent flights demonstrated the aircraft's impressive capabilities. As he flew the YB-49 around the Southern California area, word spread among aviation enthusiasts about the mysterious tailless aircraft soaring through the skies. Many likened it to the mythical flying wing of the Horton brothers, further fueling public interest in this cutting-edge design. However, the U.S. military's focused on winning the war in the Pacific, and the subsequent end of hostilities led to a reduction in funding for experimental aircraft program. This shift in priorities, coupled with the complexity and cost associated with developing the YB, caused the Air Force to cancel the program in late 1945. The military services felt that there wasn't a pressing need to develop a new long-range heavy bomber, since existing aircraft like the B-29 Super Fortress could fulfill their requirements. With the war coming to an end, the B-29 was seen as a viable solution, and the Air Force decided not to invest further resources into the Y-49. As the project neared its end, only one of the 4 planned YB-49s was completed. Designated the YB-49H, this final prototype incorporated several modifications from its predecessors. Notably, the YB-49H featured an enlarged wingspan, modified landing gear, and revised control surfaces. These changes aimed to improve the aircraft's performance and handling characteristics, showcasing the evolution of the design throughout its development. After the program's cancellation, the sole completed YB-49H was placed in storage. Eventually, it was transferred to the U.S. National Museum of the United States Air Force at Wright-Patterson Air Force Base in Dayton, Ohio. The aircraft remained in storage until 1965, when it was finally placed on display in the museum. Today, the YB-49 stands as a testament to America's pioneering efforts in aviation technology. Its presence in the National Museum of the Air Force serves as a reminder of the bold innovations that shaped the early years of military aviation. Visitors to the museum can marvel at the aircraft's unique design and the advancements it represented in aviation engineering. The YB-49 stands as a symbol of the relentless pursuit of progress that has defined the United States Air Force and the broader aviation industry. And thank you for watching. Be sure to check out our other videos. And if you enjoy what we do, please consider supporting us.